Hello, my name is Victor Maina. I'm from Kenya. I am data analytics lead for Kenya data analytics community, and today I'll be taking you through Python, uh, VS Code, and Jupyter notebooks. With no further ado, let's just get started. So, getting started with data science and Visual Studio, you need to install uh, an extension of Jupyter notebooks. So we're just going to come here, and since mine is already installed, I will just show you how to install your your Jupyter notebook. So if we come here, to extensions, you'll see a place where extensions are displayed, where you need to install your extensions. So since mine is installed, you're just going to come here and search for Jupyter notebook, and click enter. Then click at the first one by Microsoft. Now, since mine is installed, there will be no need for installing it again. So we are going to go to our presentation for today. As you can see here, my Jupyter is already installed. But if it wasn't installed, I'll just go here and click install. Next, you need to have Python installed in your computer. So mine is installed. I'm not going to go to install in Python. So that said, let's go to visualization with data science and what it entails. So visualization is very, very crucial in the field of data science. Reason because when you're given certain type of data that you don't really understand, data scientists can look at it and maybe understand it at a glance, but someone who is not very data science savvy would struggle. That's the main reason, that's the main importance of data visualization, helping people understand data better. So now, in Python, we will need a few libraries that will help us to visualize our data. The first one is pandas, the pandas library. Pandas deals more of uh, data that is in columns and rows, tabular data. NumPy, we have pandas and NumPy. These are the four libraries that we're going to use in our visualization. There's NumPy, there's pandas, there's Seaborn, and there's Matplotlib. NumPy and pandas are almost do the same thing. They help to load data in different forms and manners. So, as you can see here, we have to first import them. Import NumPy as NP, import pandas as PD, and Matplotlib. So we can run this cell. Let's run this cell real quick. As you can see, it's run. So as I said earlier, for us to read data that is in tabular form, in that columns and rows, we have to use pandas. And so this is how we load our data. For example, we've saved our data in a CSV file. And now this is the relative location of my data. This is where I've stored it in my local computer. So I'm just going to go and copy the link to where my data has been stored. And as you can see here, if you can check here, a CSV is just a file, just like an Excel file or an Excel sheet. So this is my CSV file. And today we're going to be using a movie dataset CSV file, the IMDb, the famous IMDb dataset. So clearly, this is our dataset. And if we come here and if you see this, if you can see this outlined outlined link, this is the link to where my data set is stored. So moving on, we're going to assign the URL a variable name URL2 to my data set. That said, then we're going to run it as it's been assigned. We're going to run it. It has run. URL2 has been saved. We have saved this link in a variable name. So moving on, we're going to store it in a data frame. In reading data in pandas, we use this method, data frame dot pandas read CSV. This is pandas reading our data that is stored in this link that we saved here, URL2. So we run this one. Pandas has already read our data set. So to counter check if our data has been read, we're going to we're going to display our first 5 elements in our data, the first 5 rows. So when we run this is how our data looks like. So looking at this data, it's very, very hard for someone to really understand how certain data is related. For example, when you look at here, there's rank, there's title, there's genre, and all these things. For example, what can we do when we want to check which was the most viewed movie which movie had the maximum number of votes? Because this data set is quite big, and for us to go through maybe thousands of records, that could be very tedious. So what if we use data visualization to assist us to do that? So next, we'll be using Python to help us try and see how our data really, really looks like and how things are correlated. For example, if we want to look at who is the best performing director, as we saw here, there's a director, there's a genre, and these genres have votes. So which director and the movie had the highest number of votes? Again, maybe you want to check which year was the best movie with the highest number of votes acted in. So we're going to go to and check how does our data look like, how many rows and columns does it have. So when we run dataframe.shape, it shows us the shape of our data. This the first one is the number of rows, the second one is the number of columns. And when we run this next cell over here, it tells us our number of rows is 1,000. We have a thousand rows and 12 columns. Moving on, we can see we can also write another Python code to show us maybe the amount of space that our data is occupying, the data types in our columns, and the columns that are there in our data frame. So when we run dataframe.info, it will show us these are the columns in our data set. This is the count of records that are there, and this is the data type of our data in our data set. And when we check this data set, and we saw that every row, the number of rows are 1,000. When we check here, all these rows have data, but some have missing data. But for someone who is not tech savvy or data science savvy, this will be very, very difficult for them to determine and know what this means. So how can we visualize the missing data in our data frame? So we're going first to check if they are missing data, and this is the total number of missing data in our data frame. These are the missing records. So how can we visualize? So now this is the fun part now, the visualization, seeing things in a chart that where we can understand our data better. So as we spoke before, there are certain libraries that you need to use or install for you to be able to visualize your data in data science. We spoke about pandas, and we've seen how pandas has been used over here to load our data. We spoke about NumPy, we spoke about Seaborn, and we spoke about Matplotlib. So, and if I can take you back a little bit and see how we imported NumPy, pandas, and Seaborn, and then we imported Seaborn as S and S. So when we come back here, we can see how in our data visualization, we imported Seaborn as SNS. So now we're going to get started with our first visualization, which is a heat map. A heat map is a visualization that mostly is used to show correlations, but now we can use it to try and figure out what amount of missing data do we have in our data set. So when we run this line of code, it says Seaborn, draw for us a heat map that shows us what number of null records do we have in our data. So it says df data frame, what number of null numbers do we have in our data frame. So when we run this code, this line of code, we're going to see this very somewhat confusing sorry about that, somewhat confusing diagram, but worry not, I'm here for your rescue. I will show you what this heat map really means. Let me show you how we can interpret this heat map, which is going to help us understand. We want to visualize the missing data in our data frame. So when we check here, as a heat map has a color code that has one when one in IT and in data, one means true, zero means false. All right. So what are we asking? What is null? Where there are null numbers, this is true. And when you look at this color code, it's a light kind of color that shows here that there's a true, there's missing data here. It's true that we have missing data here. So when we check zero, which is false, which is the darkest one here, it means that rank has zero amount of, it doesn't have any missing record. Title doesn't have any missing record. The only places that we have missing records are these two when we check in our diagram. And to validate our point, we're going to go back to where we said, we asked Python, please show me the places that we have missing data. And when we see here, title has zero, genre has zero, director, apart from revenue and Metascore. And when we visualize, it is very, very true here. It shows us that revenue and Metascore has missing data. As we said, true is null is true. It shows a white color. So these are the points where we have missing data in our visualization. So let's move on swiftly. We can also use another type of visualization that is called a scatter plot. And when this is visualizing the same type of data. So I think one thing we need to put in our minds, in the back of our head, there are so many types of visualization that can help us. It depends on which one you understand better or best. So for example, you do not like using heat maps. There's another option. You can use a scatter plot. So when we run this code, it's going to show us a scatter plot. So when you look at this plot, it's kind of confusing to understand it. But I think it's also very, very easy to understand. Since we saw here that only revenue and Metascore have missing values, when you look at this stars and these icons that represent our data, when you check very, very carefully, you will see this. This looks like it's a five-figured diagram, and this is a star which is pink in color, because we have two stars. One is blue in color, the other one is pink. When we look at missing data, where our missing data is at, right? It's here. These are the only two characters or icons that are showing. There's a star, and there's a rhombus, I guess. No, I'm not sure about the name, but there's this one, the revenue one, which is purple in color, and there's this pink Metascore. And the only two, if you are careful enough, you will see that these two are the only ones that have missing data. But this is in our data right now. I don't think this would be a very good visualization for us, for people who are beginning, because now it's very hard to read from this type of data, the true ones, right? So moving on, we're going to try and do something more interesting. Let's try and check, for example, maybe we have this type of data. We have a title, we have a genre, a director, actors here. What if someone asked us a question about this data? For example, who is the best performing director, right? Or which movie because we have revenue here about the movies. Which movie had the highest revenue, right? So we're going to come here. First, we're going to drop these missing values. And as we saw, we have 12% missing values here and 6%. When we drop them, here this says data frame, please drop the null values in the in the rows. Axis equals to 0 is for the rows. All right. So when we run this code, as we saw here, missing at 12% and 6%. When we drop them and check again, you see, we've dropped the missing columns. It's very, very important when you're doing data visualization and data science to know how to deal with missing data. Some may drop it. Some we may use the mean, but for us, we've just dropped our missing data. So next, let's check if we have data that is duplicated. Do we have duplicated data? Are there any duplicated data? No, false. According to this data, we do not. So now this second half or quarter is going to be, I think, the most fun part, because I will want you to ask yourself a question. When you write this kind of code, data frame dot describe, it's going to describe our data and show us how our data really looks like. I know when we used data.info here, right here, it tried and showed us something, right? But why can't we go deeper and check how our data really looks like? So when we use data.describe, which is right here, data frame.describe, frame.describe, all right, here it is. Data frame.describes, if you're not someone who does data science, if you're new to data science, this might be very confusing. For example, these are the votes, right? 8.3, 8.38, and another, there's a few more numbers, right? This might be confusing to you to understand, right? The runtime also might be very confusing. The rank. So how can we make this kind of interesting and make us understand more better? When we look at this data, yes, there's something we can learn about it. For example, we can see the maximum year. The last year was 2016. The minimum year here is 2006, right? But if you are a beginner, that would have been very hard to understand, right? So let's look at something. Let's try and visualize it. And you'll tell me if our data didn't get easier and easier to understand. So we're going to try and visualize which movie had a runtime of more than 180 minutes. This is our runtime, right? This is the count. This is the minimum. This is the minimum runtime. This is the maximum. So we want to know which movie had a runtime of more than 180 minutes, which is 3 hours. So let's try this code, right? So please do not get confused about our code here. It's very simple. We are going to go to a data frame here, check the runtime in minutes, and check which movie had a runtime of greater or equal to 180, and display it here, right? And print the number of movies with such a count runtime are. Now store it in this variable name. So there are only three movies that had a runtime of greater than 3 hours, and these are the three movies, right? So without the use of Python and data analytics and data science, it would have been very, very hard and difficult to spot this data, this type of data. But with just one line of code, we were able to visualize which movie has a runtime of more than 3 hours, right? So uh, this is another one. This is another question that we're going to ask ourselves. Uh, which year had the largest number of votes, right? Which year was the best year in movies, right? We want to know which year did the best. We can just write a simple line of code that will show us uh, which year had the greatest number of votes, and we're going to sort it in descending order, right, from the top to the bottom. All right. So uh, that said, that said, we're going to visualize this, and we can see that 2012 had the highest number of votes. It had the highest number of people who voted for movies, right? So look at this data, right? Is it very visually appealing? For me, in my own opinion, I don't think so. But now, how about we visualize it and look at uh, data that is more visually appealing, that can speak to anyone who looks at it, right? So, as we spoke, we're going to use our Seaborn library. Now, we're going to plot a bar plot. So, we are done with, we used the heat map as a visualization. We've used a scatter plot. Now, let's use a bar plot, right? And we're going to, don't worry about the code. I'm going to share the code after the presentation. So we're going to use a seaborn.bar plot. In the x-axis, we're going to use the year. In the y-axis, we're going to use the votes. And in our title, we're going to display votes by year, which will make it very, very easy for people who don't have an idea about what the data is about understand it. So let's run this code and see. All right, let me go back a minute and check votes data frame dot columns. All right, Seaborn. All right, there's an error, yes, but we can look at this visualization. It shows us these are the number of votes. This is a year, right? So in layman's language, if any layman could come and check this data, you'd know that 2012 had the highest number of votes, right? Year and votes. It had the highest number of votes, which is more than 250,000, right? 2.5 million, right? But if we check this type of data here above, it's very, very difficult to understand, right? But when we visualize it, year and votes, we can see that 2012 had the highest number of votes. 2016 had the least number of votes. So moving on swiftly. So since we are left with a few minutes, I'm going to try and rush a bit. Let's try and visualize something random. All right. So we have this data, for example, this data that no one can understand. So what if we want to know which movie had the highest revenue, or which movie had the highest revenue, right? Looking at it this way, this is just a summary, right? Data that give the summary. But what if we wanted to know more about which movie had the highest revenue? So we've just come here, write a very, very, very simple line of code. And what this code is doing, we're going to we're importing our Seaborn. We're using Seaborn here. We're using a bar plot again. But this time, in our x-axis, we're going to use the year, and in our y-axis, we're going to use the revenue, right? And plot it right here, right? So look at it. How difficult is it to understand that when you just look at it, you can really, really get that 2009 had the greatest revenue, right? And revenue in millions. So we can check, it's about around 120 million. And it's 2009. And if we check again, we can see 2016 had the lowest revenue. Okay. So we can we can move on and check something else. Huh? How were the directors rated? Right. Group by is a method that sorts values in whichever order you want. You can use ascending is false. You can use ascending is true. For example, if we look at this code here, right, run it. This one, ascending is false, means that it it shows our directors' ratings in descending orders from the top to the bottom. If we check this data, it's going to show us our highest rated director, which is Christopher Nolan, maybe your favorite director. But we could add another line of code here, right? And for example, we can check for the. Oh, sorry about that. We can check for the director, the lowest performing directors. All right. So just to save on time, let me just edit this code. So what if we sort it in descending order, right? Let's see who are the directors who are not performing very well. All right. So let's check. Let's run this code. All right. As we see here, Jason Friedberg has the lowest rating with 1.9, right? Anyway, moving on swiftly. Can we visualize this, right? Can we visualize our top 10 directors and the years and the movies? That's very easy. We just write a very simple method that gives us our top 10, our first 10 directors with the year and the title of the movie. When we run this line of code, for example, we're going to see that as much as Christopher Nolan was the highest ranked director, he also was the best for 3 years, 2008, 2010, and 2014. Oh, no, 206 too, right? He performed well in 206 also, and also in 2012, right? So he has a like 5 out of 10 is Christopher Nolan. He's like the Messi or Ronaldo of football, maybe, right? He has so many Ballon d'Ors. Like this is Christopher Nolan doing the most, right? So So let's try and visualize it, right? Let's twist things a little bit and maybe use a scatter plot. Okay, let's see. Looking at this, this is a legend, right? Don't get confused about this whole thing. But when you look at this data, we can see all these directors are color coded, right? When we look, let's not be biased and look at someone. Let's not focus on Nolan right now. Let's look at Martin. Martin has a this is a maroon, is it maroon color? Yeah, I guess maroon color. So he appeared once in 206, right? Which is not very appealing to maybe visualize that here, right? What's his name? Martin. Martin, 2006, right? But this is not very visually appealing. When you look at this data right here, it's very, very easy to see. This is a movie and the director with this color code and the year. So in 2006, Martin was a star. In let's use someone random again. Let's use maybe Florian. Florian, who has a brown color, right? Is here in 2006. Very, very easy to spot, which is not as easy to spot in this type of data. You see, I have to really, really, really check. Here they are, right? So, I guess that is data visualization and the importance of data visualization. And it really, really helps for people who are doing reporting, maybe business reports, right? Your manager wants a report at the end of the day, which product is performing the best. Would you rather present such kind of data to your boss, or this kind of data, or wait for it, this kind of data? Which would be easiest for them to, say you're the best junior analyst, giving them this kind of data that is going to take them minutes and more than 10 minutes to understand, or this kind of data that will give them maybe 2 minutes or a glance to really get what they're trying to say. Anyway, that was data visualization for me. And I'm really, really glad that this happened, because this is a very, very crucial topic. It goes deeper and deeper and deeper. And there's so many possibilities about our visualization. There's so many things that we can learn about our data when we visualize it. For example, and this is due to time, this is our last plot, right? What does this plot do? This plot shows us the movies that had a runtime, right? The longest runtime, right? The top 10 movies with the longest runtime. When we run this code, let's just run it. You can see that this was the longest movie with more than 175 minutes, right? The Hateful Eight. And when we checked here, look at this kind of visualization. It's not very appealing, but this type of visualization, it makes you want to know more about the data, right? So I guess this is me. Thank you for listening in. In case of any questions, you can ask. But far from that, I guess I'm going to hand over to. I'm going to hand
Yeah,
over to
yeah,
you.
have it. Thank you
Yes.
so much. So
Yes.
your presentation demo was really really great. I
Yes.
love the fact you used movie data for data visualization. So thank you so
Yes.
much. I
Yeah.
want just before wrapping up,
Yeah.
remember that this is the second session of the second week of the 30 days of data science program. Thank you
Yes.
everyone for joining the program. You are always in time to join it if you didn't yet.
Yeah.
And if you need useful resources about the program, please go ahead and click on this aka.ms link. This is the blog post with all the news and information you need for this week. You will
Yeah.
find a GitHub discussion to join if you want, for example, to reach out to Victor for any questions you might have. There's also a cloud skill challenge for you to learn and join a challenge. So you will really find every resources you need. And also the part you will find you can rewatch the past episodes and see when the next episodes are scheduled. So stay tuned for what's next. Again, thank you so much, Victor, and
And,
happy learning to everyone.
okay. Thank you
Bye.
so much. Bye bye.